Very good morning, and I am Dr. Shankar, and today you are going to learn about the monolithic IC operational amplifier. So here, the nowadays the world is entirely depend upon the digital ICs and analog ICs. Without that one, there is no era. So all kind of one has been depend upon these ICs. The IC has been made up of a monolithic. Mono means a single. Lithic means is a stone. So through help of stones, they have taken the layer that is silicon layer. In that they have made a integrated circuit IC. That means integrated means the 100 number of components or 1000 number of components or 10,000 number of components or 1 lakh number of components have been integrated on this silicon wafer. Then it is become called as a integrated circuit. Name is called monolithic integrated circuit. It provides the operational amp. Amp means amplifier. In this case, operational amplifier. Uh, why they given the name means the operational means it is provide the mathematical operation such as addition, subtraction, integration, differentiation with and also the amplification function. These are all they have a integrated functioning on single chip, and it is when more than 1 lakh components are being fabricated on single silicon wafer as a IC, it is called as a VLSI IC. That is a very large integrated circuit. That is called as a VLSI IC, very large scale integrated circuit. So here you are seeing here these all the components have been built on the single semiconductor material that is called the silicon wafer, and also the anything built as one pieces rather than assembled from the pieces. You are seeing that this is the symbol of the operation amplifier, and here the integrated circuit, it is having the component of active as well as passive components. Active means it is providing the power supply. That means power has been generated by itself. Such kind of components called the active component. Passive means the power has been absorbed by the component. Example, resistor, capacitor. These are all called as a passive component because it will absorb the energy. So that's why we are calling that as a passive component. In this case, an operational amplifier, it performs all the mathematical abbreviation, amplifiers, and also it will amplifies the difference between the two signals. The mainly why they have taken this operational amplifier apart from the ordinary amplifier, that is a BJT amplifier or FET, field effect transistor amplifier, because it is providing high gain and also it provides a negative feedback functioning. Then we can modify the output as well as input as our requirement. In this diagram, you are seeing the pin diagram. This is called IC741. This IC741, it is having 8 pin. The pin has been indicated here. The dot line means the pin number has been started from this side. And this is called the left hand side. The right hand side is Also the pin number 4 pins are there. The pin number 1, it's provide the offset null. The pin number 2 provide the inverting input. The pin number 3 is providing non-inverting input. Pin number 4 is called a power supply, that is called minus VCC. We have to provide only the 5 to 18 volt. The pin number 5 is offset null. The pin number 6 is called output. Whatever circuit you have connected, you can take the output from the pin number 6. Pin number 7 is a positive power supply. Pin number 8 is a no connection. And more important, these op-amp, it is having the characteristics. We can separate in a two kind of mode. One is the ideal mode. That is with the help of mathematical configuration, we have obtained many parameters. And when we are come into the practical manner, that characteristics will be changed. And due to some reason, we won't get the same characteristics of ideal condition due to several disturbance and some internal functioning. The electron has been internal functioning, we won't get the same kind of ideal of characteristics. So ideal amp means with the help of mathematical equation, we are providing the open loop gain of amplifier of amplifier must be infinite. That is a very large amount of gain must be given. And the input impedance should be the infinite. Output should impedance should be the 0. Another, the CMR or rate should be infinite. The bandwidth also infinite. Large bandwidth of signal can be amplified, it's indicating. And also it is providing the zero offset null. What is zero offset null means? Due to the leakage current, it is disturbing the amplification. So in order to avoid that one, we have to nullify this reverse current in a op-amp, because the operational amplifier is called as a differential amplifier. It has two BJT circuits and or FET. So this one only it is having the base, collector, emitter, both are connected in back to back. And this one provides some kind of leakage current, that is called ICO. That one, it will disturb the gain and other kind of parameters. So that's why in an ideal case, it should be 0. Then only you will be getting infinite gain, infinite input impedance, output impedance will be 0, and the CMR, or that is common mode rejection ratio, will be infinite. So this is the ideal case. But when we go to the practical case, you won't obtain the same one. Practical case, you won't get the same one. What here means, due to the parameters. What kind of parameter is disturbing the exact ideal characteristic? One is, it has been categorized into two manner. One is the DC character, another one is AC characteristic. DC characteristics, one is called input offset voltage, second one is input offset current, third one is input bias current, fourth one is a large voltage, fifth one is called thermal drift. So this is comes under DC characteristics. AC characteristics, bandwidth, second one is a slew rate, third one is a common mode rejection ratio, fourth one is a frequency response. So you are seeing it here. And frequency means due to the high frequency, it will vary the gain. The frequency response means it will improve the stability of amplifiers through the they have to go for frequency compensation because due to the electron mm, random motion, it was changes the frequency of input signal. We have to nullify that kind of thing. We have to go for the compensation. Compensation types, one is a external compensation, another one is internal compensation. External compensation means we are adding the resistor capacitor in the output of the op amp. From that, we are nullifying the disturbance due to the frequency has been created by the op amp. And the second one is a internal, that is called Miller compensation circuit. Miller means the inside the integrated circuit, we are providing one capacitor. With the help of capacitor, it will nullify uh, the frequency has been nullified with the help of this capacitor. So internal compensation, there is a two stage, stage 1 and stage 2. So both it has been given to the differential amplifier. The capacitor is connected inside of the amp and the capacitor, it will provide the improvement of stability and also it will prevent the oscillation inside that one. Fourth one, the sleeve rate. The sleeve rate means rate of change of in output voltage on the input voltage. That is given in the mathematical equation, that is dV naught divided by dt at a maximum voltage. Here the unit is volt per microsecond. The sleeve rate usually we can mention in the in terms of frequency and its amplitude, that is called 2 pi fm Vm. Suppose example Vm is 4 volt, the fm, the frequency is 30 kilohertz, the sleeve rate it will be around 0.1884 voltage per microsecond. So method of improving this sleeve rate, one, the open loop gain must be increased. Another one is transition frequency must be increased. So another one, the closed loop gain should be increased. The frequency must be in minus 3 dB level frequency. The differential amplifier is called, what is the differential amplifier means? The two input signal as given, in that it will subtract these two input signal V1 and V2, it will provide an amplified output signal, that is called V0. So V0 is directly proportional to V1 minus V2. So this is the diagram of a differential amplifier. So differential amplifier, we can obtain the AD, that is called differential gain. The differential gain is we can obtain, which is equal to V0 divided by Vd. So Vd is, we know that V1 minus V2. So that means AD will be 20, that is a differential gain, 20 log base 10 AD in dB. Common mode gain, that is common mode gain we can obtain with the help of this equation, that is common voltage which is equal to V1 plus V2 divided by 2. Therefore, the V0 we can write it as AC, that is called common mode gain into Vc, that is common voltage. Therefore, V0 equal to the output voltage is the combination of ADVD, that is called differential gain, differential voltage plus common gain and common voltage. So when we take these two kind of functioning, the common mode rejection ratio we can obtain. That rejection ratio is denoted by del, that is called CMRR, which is equal to the mode AD divided by AC. That is what is AD means differential gain divided by common mode gain. In terms of a logarithmic function, it is 20 log base 10 AD divided by AC. So this is the internal diagram of a operation amplifier. So here the IC manufacturing process, it has two types. One is a monolithic IC, another one is hybrid IC. The monolithic IC is divided into two types. One is a bipolar IC, another one is unipolar IC. Unipolar means it has been made by JFET and MOSFET. So the overall you are seeing here, there will be a data sheet is available for all the ICs. So usually the op-amp IC is number is denoted as IC741, and these are all AC characteristics. The main application, what is the main application of these ICs? You can obtain it. Okay, thank you for seeing this one. I'm really happy to you are learned related with the op-amp and its functioning, and we'll see this class tomorrow. It will be effective. Thank you for